All right. I hope we're recording here. Yeah. Okay, so let me come back to you guys. Yep. And I'm going to share my screen and pull up our document for today. So today we're taking equations that we've already been learning, and now we're putting fractions in there. So that's why it's always important to practice what we learned the day before, because we always add to it. So if you're shaky on solving equations, now we're adding fractions to it, you're going to be even shakier. So try to always do your homework in advance so you get it all done and everything, because now we're adding fractions to the mix. So the directions right here say to eliminate fractions, determine the least common denominator for all of the fractions in the equation, then multiply both sides of the equation by that LCD. Okay, so we have two fractions in number one. Oh, Erica, it's so good to actually see a face. I feel so lonely most of the time. Thank you. I love seeing your faces. Okay, so we have two fractions here, and do we already have a common denominator?
Yeah, the 9.
Right, yeah, we already have a common denominator. Now there's two methods to solve this. In this problem, really, we don't have to necessarily multiply out the denominator. I'm going to show you both methods, but since we already have a common denominator, this one wouldn't be too hard to just keep the fractions in there and solve. So what would I need to do to solve this for x?
Add 7/9 or
So are we trying to bring this over with the x?
oh, you would have to do minus 1/9.
Yes, exactly, because we're trying to get the 1/9 gone, so we get x by itself. All right, so I also we'll have 1/9 here. So that cancels out the 1/9. And what does that give us? What is -7/9 and -1/9?
You said -7/9 minus -1/9.
6/9.
Well, not minus negative, just a minus. So, or you can think of it as a -7/9 and a -1/9. So if they're same signs, do we add or do we subtract?
You add.
Add and give it the sign of both, right? So what would our answer be?
Like 8/9.
Okay, and what sign?
Negative.
Positive.
Each of you said one. Well, one of you is right.
Positive.
Well, remember, a negative times a negative is positive, but when we're adding same signs, we give it the sign of both. Because imagine if we go down the number line, because that's negative, and then we go down the number line even further, we're still down the number line in the negatives.
Yeah.
Yeah, so when we have same sign, we add and give it the sign of both. So -8/9. Okay. Now, the method that we're going to learn, but again, you can determine when you want to use it. In this case, that was easy enough to do without, just by keeping our fractions in there. But the other method we're going to learn is, so if we have x plus 1/9 equals, you know what? I'm not even going to show it on this problem. Now that I think of it, really, well, yes, I am. Sorry, I'm kind of thinking about that.
Okay.
So the other method is that if ever you have an equal sign and you have fractions, you can multiply out the LCD. So we already determined that our least common denominator was 9. So what you do is you multiply every term, because remember, there's a rule that whatever you do to one side, you have to do to the other side of the equation. And that means to all terms, because if I do something to this whole side, it would get distributed. Like if I had parentheses and I did something to the whole side, I would have to distribute it. So basically it means I'm going to do it to all terms. So I'm going to multiply by that LCD. I'm going to multiply every term by 9. So I'm going to multiply that term by 9. I'm going to multiply this term by 9, and I can make it 9 over 1 right there if I want. And I'm going to multiply this term by 9. I just put a 1 under these because these two were fractions, but 9 and 9 over 1 is the same thing.
Yeah.
Now, the reason why we're going to do that is then we can cross cancel our denominators. So this isn't a denominator, so I'm just going to carry that down. That's just now 9x.
Damn, that's confusing.
It won't be after we do it a few times. Now, the whole reason why I multiplied by 9 here was so that I can cross these off. Remember cross canceling? If you see the same number, they cross off and become 1s. Uh-oh, what's going on with my margin there? Oh my goodness, I'm having technical issues. These cross off and become 1s. So if this is 1 times 1, then it's just plus 1. My fraction is gone. Okay, here my 9 and my 9 cross off, right? Again, if you have the same one in both spots and my fraction's gone. And the whole reason why I picked a LCD was because I picked a number that all of my denominators will become 1s. They'll go into it. So now I just have -7. So on that very first step, I now don't have fractions I have to deal with. Then we would just subtract the 1. So I would have 9x equals, and -7 and -1 is -8. And then my last step would be divide by that 9. And see, I'm going to get the same answer that I got right here. I'm getting -8/9 that way as well. But again, it's almost more work to do it if all of our denominators are already common denominators. Then it's hardly worth it. Okay, so we already have common denominators in number 2. So what do you think we should do first?
X plus 4 plus -4.
Say that again.
5x plus -4.
Okay, so combine our like terms. So what's 5x minus 4x?
1x.
Yeah, just
X.
x. Okay, so we have x plus 1 over 11 equals 2 over 11 minus 5 over 11. Now what?
I would move the 111 to the right side.
All right. So we already over there, we already have 2 11s and a minus 5 11s. And what happens to the 1 11th if we move it?
You just add it all and subtract it.
But what happens? So I haven't yet put my 1 11th over here.
Oh,
So
it would turn negative.
right, if it's positive on this side and we want to move it over here, it becomes negative, right?
Yeah.
Erica, are you all good with us here?
Yeah.
Okay, so first we combine like terms here, and we moved our 1 11th over here to be with these other constants. So I have my variables on this side combined into 1, and now my 1 11th we moved over here. Now again, this is one of those occasions where I don't think it's worth multiplying out the LCD because, you know, they're all the same. So we don't have a lot of work to do. We just have to move it, but that's all. Now what?
You would hold up, 211.
-411.
Yeah, because 2 minus 5 is -3, right? Because 5 minus 2 would be +3, but smaller minus bigger, so -3, and then a -3 and a -1. -4. Yeah, good. Over 11, of course.
Yeah.
Patches, are you writing these all down?
Yeah.
Good. All right. Any questions on numbers 1 or 2?
No, I'm good.
Okay, so I would say if you have all common denominators, I wouldn't really necessarily use the method of multiplying out the LCD. But if you don't have common denominators, that's where, believe me, even if it's a little confusing at first, you should practice it because it makes a world of difference for the rest of your math career if you understand that you could just multiply out the LCD. All right. So for number 3, our first step is to look at whatever fractions we have in there and find the LCD. So what is the least common denominator in this problem?
9.
3.
So Patches, you said 3. Erica, you said 9.
Yeah.
Yeah. So 9 is right because remember, Patches, it like 9 wouldn't be able to multiply by something to get 3, but 3, remember how we always start with our bigger denominator?
Oh, yeah.
Back to the fraction chapter there, we start with our bigger denominator, and if the smaller one goes into it, we pick that. If not, then we start with our multiples of that bigger denominator. Okay, so 9
Yeah.
is our common denominator. So now what I would suggest is you write this problem again, but you leave some spaces in front of each term. So
Shit.
rewrite it, leaving some spaces. Okay. Now, it's also important to establish how many terms you have, because whenever you multiply by your LCD, you have to do it to all terms. So we have the y as a term. Remember, terms are separated by pluses, minuses, and equal signs. So we have 3 terms. So we have to make sure that we multiply all 3 terms by 9. And you always multiply every term by the exact same number, because there's that rule, whatever you do to one term, you do to all terms. So we're going to multiply every term by 9. So that one by 9, this one by 9, and this one by 9. And if you want to put the second 2 over 1, that's fine. Or you can just put it up there. Just put it in the top though, because it's 9 over 1 technically. Now what should we do from what we did on the number 1?
So it's 9y minus, then I do 9 times 8, right?
Well, no, because remember the reason we put this here is to cross cancel with this 9. So now 9 and 9 cross cancel, right? 9 goes in, we can divide top and bottom by 9. So that cross cancels my 9.
I'm still kind
The
of
whole-
like confused on how you got a 9 next to y.
Because our LCD was 9 and we're multiplying everything. So you remember the steps up here where then multiply both sides of the equation by the LCD. So whenever we pick, we're allowed to do anything we want to an equation as long as we do it to both sides, which means to all terms. So I have to, if I'm going to multiply one term by 9, I have to do it to all 3 terms to keep it still equivalent.
All right.
Okay. And then this one didn't have a denominator to cross off with. So this one just stayed 9y. But these, the reason why I'm putting these here, our goal is that every denominator becomes a 1 so that we can drop it and we have no denominator, we have no fractions.
All right.
So now we just have an 8. And we're going to cross cancel this denominator into 9. And remember, our goal is to make every denominator a 1. That's why we pick an LCD, which is a number that all of these would go into. If we only picked 3, this one would have crossed off, but this one wouldn't have. We would have still had a denominator. So how many times does 3 go into 9?
3 times.
3 times. So we're going to cross it off and put a 3. So now we're just multiplying 3 times 1. So what are we going to get here?
3.
Yeah. And just like that, we don't have to deal with fractions anymore. I don't have to add 8/9 over to this side and try to find a common denominator and keep our fractions and all of that. Now I get to just deal with it like a regular equation. So what would our next step be?
Move the -8 to the right side, turn it into positive, so it'd be 3 plus 8.
Okay.
And then that would do 11 on the right
Okay.
side.
Okay. Then what?
You divide both
Mm.
by 9.
Yeah.
Yeah.
Wait, can I? Oh, never mind.
So what's our answer then?
Doesn't 11 divided by 9 you'd be like a decimal?
Yeah, so we won't turn it to a decimal. If you ever get a fraction, you just have to check that it doesn't need to be reduced, but 11/9 can't be reduced, so we'll just leave it.
So y equals 11.
Y equals 11/9. Yeah. Any questions about multiplying out that LCD?
Nah, I'm good.
You're getting it?
Yeah.
All right. In number 4, how many terms do we have?
One. One term.
Remember, terms are separated by pluses, minuses, or equal signs.
So 2 terms.
Yeah, what's our first term?
1/5 x and 20.
And yeah, so we have 2 terms here. So that means when we figure out an LCD, we have to multiply both terms by that. But there's only one fraction. So what is my LCD? What'd you say, Erica?
5.
Yeah, if you only have one fraction, then that's the only denominator you're trying to get rid of, right?
Yeah.
Yeah, so we'll just pick 5. If we have more than one fraction, then we have to find the LCD. But if we only have one fraction, we get to pick that. So 1/5 x equals 20, and we're going to multiply by 5. And remember that we would have done that anyway. We learned how to do this before. This is the set 1/5 x is the same as x over 5. And so 1/5 x and x over 5 mean the same thing. And remember, if we're dividing by 5, we multiply by 5 to get rid of it. So we would have done that anyway, but we're going to multiply by 5. But whatever we do to one side, we have to do to the other side. Now, again, don't multiply this 5. Whenever we put a number by the fractions, that number is not going to stay there, because our goal is that we're using that number to cross cancel with our denominator. So now it will stay there. If you don't have a fraction, we'll multiply these. But if ever you have a fraction, it's going to cross off and become something. In this case, since they're both the same, it becomes a 1. So what do we get for our answer?
4.
What did you say, Erica?
4.
Well, no, so this isn't a 20. This 5 is not like in a denominator, right? We multiply by 5. And
So
then,
that'd be
so what?
would it be 1,000 on that side?
Do
No.
your math again.
Hold on. 2, 4, 6. Oh, 100. Sorry.
Yeah. So Erica, just 5 times 20. There's no cross cancel.
That's why I thought 5 times.
Yeah, that's a common mistake. I'm actually glad you kind of thought about that, because every student thinks about that. They want to kind of cross cancel the 5 and the 20, but neither of these are a denominator. So it's not like one's a numerator and one's a denominator. So we're just going to multiply them. Yeah. Oh, goodness. Just a sec. I'm trying to move this thing back down. There we go. Okay, what about number 5? You guys tell me what you think. Talk me through it.
There's only 2 what you call it? So
Terms.
yeah. You can find the LCD or something. I think that's the 6.
Okay. And then I always rewrite it to give myself space to put in those numbers.
Yeah.
So now what?
think you said multiply was the next step.
Okay, multiply by what?
6.
Yeah, the LCD 6, right? And if you like to put 6/1, that's fine. You can do that. Or if you're comfortable with just putting a 6 there and knowing that it's in the numerator, technically, that's fine too. So whatever if you want 6 or 6/1, that doesn't matter. Now remember, our goal is don't multiply these two together. Our goal is to always do some cross canceling. We want our denominators to become 1s. Okay, so what's going to happen with this 6 and this 6?
You would divide by 3.
Well, if we divide by 3, then I'm going to have 2 left. Remember, I want to have 1 left. My goal is to make my denominators equal 1.
Divide by 6.
Right. And so whenever you have the exact same number, those cross off and become 1s. Remember back to the fractions chapter.
Yeah.
So if ever you have the exact same number, they cross off and become 1s because we're dividing both by 6. So if we do that, what do we have left right here?
Would it be -1?
Right here, -1?
No, the -5.
So this is 1 times -5, because we were multiplying, so it's 1 times -5x, which would be what? See, this 6 is gone and this 6 is gone and it became a 1. So now we have 1 times -5x. So what's 1 times anything?
1.
No.
1 times anything is a number you're multiplying it by 1.
Oh, -5x.
Right. Yeah, 1 times anything is that other number. Okay, and what are we going to do on the right side?
The same thing.
Okay, meaning what?
Multiply it by 1.
Well, no, we haven't done our cross canceling yet. And not all our cross canceling is going to give us a 1 up here. It's going to give us a 1 down here because we picked an LCD. We picked a number that all of our denominators will go into. So we'll always get a 1 down here, but we won't always get a 1 up here. We'll only ever get a 1 up here if they're the same, if the denominator and this number are the same. But here it's 3 into 6.
So 2.
Yeah. So this becomes a 1. Our goal is denominator because we're dividing by 3, and 6 divided by 3 is 2. Does that make sense? We're cross canceling.
Yeah.
So we divided by 3, or we say 3 goes into 6 twice. So now we're multiplying these two together, and what do we get?
Wait. Which ones are you
You're multiplying 2 by -5, right?
No, we're right here. -5's over on the other side of the equal sign.
Oh, wait. So then it would be 2 times, what's that, a 2?
Mm-hmm.
Which is 4?
Right. Do you guys see that?
Yeah. Yeah.
Yeah, don't make it harder than it is. Like this 2 doesn't get multiplied way over here. We just had 6/1 times 2/3, and we're just trying to do that math. And we cross canceled, and we get 2 times 2, which is 4. Erica, do you see that?
Yeah.
Okay. Then what?
Divide by -5.
Divided by 5, and then the answer is x equals 4/5.
Oh, what about that? I know you don't like negatives, Erica,
Negative.
but what is it going to be?
-4/5.
Yes. Yeah. All right. Any questions on that one?
No, I'm good.
Yeah, the more you do it, the easier it comes. All right. Let's see. Patches, you kind of started us off on the other one. Erica, can you start us off on this one?
So the least common denominator would be 5.
Would be what?
5.
Oh,
Well, does 3, so we start by looking at our biggest denominator. Does 3 go into 5?
No.
No. So we have to pick one that they both go into.
Okay. 15?
What?
15?
Yes. Yes, or LCD. And I would always just kind of make a note to yourself. LCD is, oh, I don't know what I was saying, 6 is 15. I was still thinking of the last one. Yeah, so LCD is 15. Now what?
I multiply.
I can barely hear you, Erica.
Then you multiply 15 times 2/3.
Okay. So, and how many terms do we have in this problem?
3.
Yeah. That's a term. That's a term. And some people think, oh, I only have to do it to the two fractions. I don't have to do it to the -6 because it's not a fraction. But remember, the rule is whatever you do to one term, you have to do to all terms. So I'm going to rewrite this to give us some more space. And I would do that if I were you also.
Yeah, that's what I'm doing.
Okay. And just leave space in front of each number. So what did you say we're going to multiply by?
15 times 2/3.
Okay.
And then 15 times 4/5.
Okay.
And then 15 times -6.
Okay. Now what?
And then 3 goes into 15 5 times.
Very good.
Oh, what the?
And then 5
Oh, I was correct.
3 times.
What?
5 goes into 15 3 times.
Oh, over here. Okay.
I have a question though. So you know when we cancel them from the bottom, I feel like for some, I don't know why, but I think of like doing, you take off the 3 and put a 2, and I know that's not what you're supposed to do, but it's just like
Right here, you're tempted to put a 2 right there.
yeah, like I know I'm not supposed to, but I feel like I would probably end up doing that.
Well, because remember what we're doing. Let me just take that 1 off for a second. What we're really doing is we've determined that 3 goes into both 3 and 15. So remember, we're really dividing by 3, right? So 3 divided by itself is 1. And over here, we're dividing by 5 and 5 goes into 15. So we're taking 5 into 15, or we're dividing by 5, and anything divided by itself is 1. Does that help a little bit, or?
Yeah, no, that does.
Okay.
And then 15 times 6 is -90.
Okay. Yeah, and that one, there's no cross canceling, right? Because the 6 isn't a denominator. So yeah. What are we going to get over here?
Do I then do 5 times 2?
Yeah, 5 times 2, and then there's an X also, but yeah.
X. And then -12.
Yeah. And see with that, like, look, ooh. Look what a mess this would have been to try to solve this. And, but on this very first step of just multiplying everything by 15, no more fractions to worry about. All right, Patches, now what?
Now you would move your -12 to your right, turning it into +12.
Okay.
And that would give you
10x equals
78.
And what sign?
That would be negative 78.
Okay.
Then
Then
we'll
what?
divide by 10 on each side.
And what you guys want to be careful of when you submit homework in My Lab Math is to read what right under the answer blank, they're going to tell you how they want the answer. So if they want it as a fraction in lowest terms, we need to reduce this fraction. If they want it as a decimal, we would have to divide. So let me go right here. So right now we have x equals negative 78 over 10. They would definitely count that wrong if we put it in there because it's not in lowest terms. So how do we get that in lowest terms?
I think that is the lowest terms, wouldn't it? 4/5.
Negative 78 over 10?
Oh, I'm looking at the wrong one. I guess you could divide by 2.
Yeah, if they both end in an even number, then 2 goes into both for sure. Tell me what you're going to get.
That would be
39 over 5. Negative 39.
I was just going to remind you. Yes. Now, does that look like it's in lowest terms?
No.
yeah, because I don't think 5 could go into. Well, actually, you could divide 5 by 5, but I
Well,
don't think 39 would go into that.
right. If I divide by 5 down here, I would have to divide by 5 up here, but 39 isn't divisible by 5. And that's the only thing that I could divide by.
What's the lowest term?
Yeah.
Got a second.
Okay. Any questions on that one?
Nah.
Okay. Patches, talk us through number 7.
All right. So on the right side, x over 6 will be x divided by 6, right?
Yeah.
So then I would move the divided by 6 to the left.
I don't think we really need to do that. We already have our 2 constants together on one side and our variable on the other. So I would just kind of keep them that way because our goal is to get our variables on one side and our constants on the other.
So then find a common denominator.
Yeah.
It would be 12.
Yeah. Did you figure that out, Erica? 12? Because 4, 3, and 6 all go into 12. And remember, the way to do that, you guys, is look at your biggest denominator and start with that one. If both of the others go into that, we get to pick that, but if they don't, so then you do the next multiple of 6, which is 12, and both of these go into 12. So, all right. So now what?
You would multiply by 12.
Multiply what by 12?
The 4 and the 3.
Like that?
Yeah, that's for the bottom parts, right? You put that for the 4 and the 3.
Well, but it's in the numerator. It's not going down in the bottom with them, right? It's like 12 over
Yeah.
1. Okay. Okay. What else?
You would multiply straight across. So
You mean
like 12, 3, 4 times 1. And the same thing for the other 12. 2 times 12, 3 times 1.
Remember, our goal for putting these up here is to not have a denominator anymore. If I use the 12 and multiply, I'm still going to have over 4. That won't help me, right? Unless you then reduce that. So remember what we did in all these others was cross cancel, right? We're trying to get our denominators to be 1.
So then you would cross cancel the denominators and for the numerators, would you divide by 12?
No, we're just trying to, this is just like, let's detach this first term back to the first week of class. We're just trying to multiply these. We're going to cross cancel first, which will do what to it?
Cancel the denominator for the 3/4.
I did not understand that.
You would cross cancel the denominator for the 3/4.
Okay, what does it become?
A 1.
Okay, what else?
The same thing to the other one, 2/3. 3 becomes a 1.
Well, no, we can't just cross a 4 off. We've got to cross cancel. You can't divide the bottom by 4 and not do the, remember, whatever you do to the bottom, you have to do to the top.
Right. So then you would cancel the 12.
And make
That-
it what?
A 1.
No, these aren't the same. Remember, these are, if these are the same, they both become ones, but 4 doesn't go into 12 just one time,
It goes into 12 3 times.
3.
3 times, right?
Yeah.
Have you been with us, Patches, or are you
Yeah.
preoccupied?
Still kind of confused on the after like the cross cancel part. I'm still kind of blurry there. So then
So-
for the other one, you would do for like the 2/3 of 3 would become a 1 then, right? And then the 12 would become a 4.
Exactly.
And then,
Erica, is there anything missing here?
12 times x over 6.
Yeah, don't forget you've got to do that to all terms.
And then 6 goes into 12 2 times.
Okay, and just like that, our denominators are gone, right?
Yeah.
But are you understanding that cross canceling, Patches?
It's still a little confusing, but it's just like practice makes perfect kind of thing.
Mm-hmm. Yeah, and so what we're crossing off the 4 because we're dividing. We picked a 12 because all of these go into 12, so that's how they're all going to become ones. And then they go into like 4 goes into 12 3 times, and 3 goes into 12 4 times, and 6 goes into 12 twice. Now what do we have? Now we multiply each of these things that we have.
9 minus 8 equals 2x.
Yeah.
Oh, that's right.
Mm-hmm.
Because you know x over 1 x. That's like,
Yeah, but whenever we have, look, we have all ones down here. 1 times 1 for that one, 1 times 1 for that one, 1 times 1. And so that means anything over 1 is just the top number. So that means we get to drop all the denominators. We just worry about multiplying these numerators. Okay, then what?
1 equals 2x,
Okay,
and then you divide 2, or
yeah, exactly, because we're trying to get x by itself. Yeah. So what does x equal?
x equals 1.
So the 2's cross off here and we get x on this side, but do we just have 1 on this side?
No, you have 1/2.
Right.
Oh yeah.
Yeah, so, yeah, because we had 1 and then we had to divide by 2. So 1 over 2, 1/2.
It's a lot of steps to it.
It is, but look how quick you'll get faster at this. You'll end up, if you do this enough and you actually practice, you will be able to do this first step in about 20 seconds. And then just like that, no more fractions. So much easier. Like here, this would be a pain to have to find a common denominator for everything and then keep our fractions in there. And all right, talk me through number 8.
The least common denominator would be 18.
Very good. Yeah, start with the biggest denominator, which is 9. 3 goes into 9, but 6 doesn't. So you do the next denominator, the next multiple of 9 is 18. They all go into 18. So there it is. Patches, now what?
Now you would cross cancel, right?
We don't have anything to cross cancel there yet. Are you working these along with us?
Yeah. Just still kind of shaky. Okay, let me see then. Oh, least common denominator, which is 18, right?
Yeah.
You would multiply each fraction by 18 over 1. And then you would cross cancel, right?
Okay.
You would cross cancel the each denominator, so that 9 would become a 1 and that 18 would become a 2. For the next section, the 6 would become a 1 and the 18 would become a 3. The next section, the 3 would become a 1 and the 18 would become a 6.
Okay.
Next, you would multiply straight across the numerators.
Okay.
So 2 times 5 is 10. 1 times 3 is 3.
So back to that 10. What else is there?
10x.
Yeah, x. Forgot about the x. Then 3 times 1 is 3. Minus 6 times 2 is 12.
Okay.
Let's see. The next step would be you would do what's on the right side first, right? So 3 minus 12, which would be negative 9.
Okay.
And then you would divide by 10. Wouldn't that be the fraction right there? 9 over 10, negative 9 over 10.
Yeah. Nothing we could do about it.
Yeah.
Erica, were you good on all those steps?
Yeah.
Okay. All right. I'm going to give you guys about 3 minutes to work on number 9. And that means actually work on it and get an answer. And I'm going to hear what both of you get and we'll see how it goes. Also, remember how to check this. This is a mistake people make. How many terms are in this problem?
4.
4.
Right. So don't multiply by the LCD only on the fractions. The rule is you have to do it to every term. Okay, go for it.
$15.
Any answers yet?
Almost.
Sure yet, but
Okay, that's fine. Take your time.
So what's this? 3/1 times. Oh, shit. Y over 1 minus 2 equals 5/1 times y over 1 minus 4. Right. Oh, crap. I think I may have fucked up. 3 times 1 is 3. 3 y. No. Yeah. 5 times y. 5y. 4 minus 2 equals 3y minus 2 equals 5y minus 4. And that is, let's combine my terms. I'm confused as hell.
Yeah, and you missed something. Right before you guys did it, I said, now don't forget something. And you forgot already. Erica, did you get an answer yet?
well, I got stuck right here where so I got it to 3y minus 30 equals 15y minus 60. And I don't know if I do like plus 30 on both sides or like a minus 3.
Okay, so let me catch up to you. You made one mistake in there, Erica, and then Patches, you made 2 mistakes. So what did you guys determine was your LCD?
I got 15, I think was mine. Yeah.
Okay, and how many terms do we have?
We have 4.
Okay, did you multiply all 4 terms by 15?
Yes.
Oh,
Yeah,
I think
you
that's
did.
where I messed up.
Yeah, you didn't do the numbers. And remember, right before we started this, Patches, I said, now the mistake a lot of people make is they only focus on the fractions. But the rule is, if I'm going to multiply by something, I have to multiply all terms by that exact same thing.
Right. Yeah, that's where my mistake was. Let me try this again.
Okay. And then Erica, you have one, you did that, I could tell, but you made one mistake and we'll get to it in just a second. And that's a common mistake, Patches. That's why I mentioned it ahead of time. It happens a lot that students kind of focus on the fractions and they ignore any terms that aren't fractions, but the rule is you have to do it to all terms. So Erica, now check. Your mistake is on your next step. And on one of these terms, you made a mistake. So now check your work real carefully on each of these.
Because 5 goes into 15 3 times.
Okay.
So I canceled out the 5 and put a 1 and then put a 3 over the 15.
Okay.
And then I did 15 times 2 equals 30. 3y equals 3y minus 30 equals, and then 3 goes into 15 5 times.
Yeah.
And then 15 times 4 equals negative 60.
So what do we have for this term?
15 5y.
Yeah. And you said 15y. I don't know if you had 15y on your paper or not.
I don't know why I wrote that because I know it was
Yeah, you did the cross canceling.
of all the 15s, I'm like 15.
Yeah.
Yeah, everybody right.
So 5y minus 60.
Yes.
And then after that, do I just right here? That's where like I do the line in the middle that you say to do sometimes.
Yeah, you can do it that way. Draw a line down there and get your variables on one side and your constants on the other. And it doesn't matter which side you take them, but you just want all your variables together and all your constants on the other side.
with this, I just don't know if you could do like either or, as in what I mean by that is like minus the third plus 30 or like minus 3y minus 3.
It doesn't matter. You can take the 3y and subtract it first. You could take the minus 30 and add it. You could take this 5y and subtract it, or you could take the minus 60 and add it. There's no right or wrong first step.
Okay, so if I were, because I was doing the plus 30, would I do the
Okay.
under the 60?
Plus 30 under the 60, did you say?
Yeah, so it would be negative 30, right? And then
Yes. So what do you have?
sorry, 3y equals 5y minus 30.
Okay. Now what?
And then 5y.
Wouldn't you move the 5y to the left side and turn it
Yeah.
into negative?
Yeah. And Erica, does that make sense? Like, it really doesn't matter if you're sitting there thinking, I'm not sure if to move the 3y or the 30 or the 5y or the 60. It doesn't matter. You can choose any of those four terms, as long as then your next step, if that moved your variables to one side, then you make sure you move your constants to the opposite side. And with your step, you moved your constant to the right. So that means your variables need to go to the other side. So what do we have now?
You have what's that?
Negative 2y?
Yeah. And on the right you would have just 0 for the y part, and then minus 30.
Equals
So just negative 30 then.
Yeah.
and then you divide it by 2.
Negative 2.
Thanks, Patches. Erica doesn't like negatives, but we're going to make her love them or hate them. I'm not sure which.
So y equals, would it be positive 15?
Very good. Negative. This is one time I'm going to allow you to say positive. Yes. Negative over negative is positive.
Boom.
Yeah, because I saw it was like negative 30, negative, you know.
Yeah. So you guys are really close to getting this. I mean, I think you understand the concepts. It's just, it is easy to make mistakes. So both of you would have gotten it wrong from making little mistakes. I think Patches, yours was you forgot your two terms that weren't fractions. And
Yep.
then Erica, yours was more careless, Eric, because it sounds like you even cross canceled and got 5, but then you still said 15. So
No, yeah, that's like, I don't know why I said 15. It was just like, I knew it was 5.
yeah.
I don't know how I somehow carried all that.
Yeah. All right. I'm going to sit back and let you guys each do number 10 and tell me what you get. I'm going to stop sharing my screen just for a minute to pull something up here. You guys have it written down, I'm sure.
I don't know if I'm right.
What'd you get?
X equals 5.
Okay, we'll see. Patches, are you done yet?
I'm still working on it.
Okay, what step are you at?
I'm still on the cross canceling. I might be stuck here for a little bit, but I'm not 100% sure. So I'm just gonna move forward. It's gonna be a
Just
4.
make sure that
What'd you say, Erica?
I'm just gonna
equals
make sure that
You're gonna double check your work?
yeah.
Okay,
5 times 1 is -5 times, what's that? Since -4 is -4. So -4 1. Wait. -5 minus 4. What the hell is that? That's -9. 4x equals. No, I just got to divide by 4. 9 negative divided by 4 equals. What the? Okay then. Well, I got 4x equals -9.
okay, so you're not done till you get X, right?
What?
So you're not quite done yet, then, if you have 4x equals -9?
Well, I tried dividing each by 4, but I'm pretty sure that's gonna give me a decimal on the -9 side.
Well, remember, we won't turn it to a decimal necessarily. We'll just leave it as a fraction. Remember, several of them didn't divide, right? We got 1/2, we got -9/10. So you could definitely get a fraction, but don't turn it to a decimal. Just leave it as a fraction.
So then there would be x equals -9 over 4.
Okay, so you must have made a mistake somewhere along in there. Erica, did you catch any mistakes?
I don't know. I don't know. It's
Okay.
fine.
Well, each of you must have made some mistake. We'll see. You'll have to tell me where you went wrong. So what is
feel
the
like-
yeah?
I feel like I went wrong on the cross cancel part, somewhere around there.
Okay. What did you pick for your LCD?
18.
Okay. Did you pick that, Erica?
Yeah.
Okay. So we have -7/9 x equals -5/18 minus 4/18. So did you remember to do multiply by 18 on all terms?
Yeah, so it'd be 18 over 1 for that one, 18 over 1 for the next, and then 18 over 1 for the last part.
Okay.
I think this is where I messed up. Is I crossed out the 9, that turned into a 1. Oh, I think I know where I messed up. Okay, so this is where I messed up. Instead of putting like a 2 up where the 18 is, I just put 1 on each. So the next one would be 1 on the bottom, 1 on the top.
Yeah.
Yeah, that's where I messed up. And then same thing for the other one.
Yeah. So remember, if you have the same identical number, bottom and top, then they both become ones, but that's not always the case, because if the denominator isn't the LCD, it's going to change. It's going to go in there more than once.
Yeah.
So is it x equals 13?
No. So what do we have now?
Cause I got confused in the last part, you know, where it says 5/18 minus 4/18. I don't know why I put 5/18 minus -4/18. That's
Yeah,
what
it was just 1 minus, so don't add an extra negative in there. Yeah. Did you then cross cancel, Erica?
yeah. Then I did the 2 times 7 equals 14, -14,
Thank you. Very good.
and equals 1 times 5, -5. And then 1 times 4 equals 4.
And what sign?
Not negative.
Right.
-4. Wait, see,
Yeah,
that's
just
what I -4.
or just minus, this is a minus sign, so it just continues to stay minus.
Okay. So And then I did 5 minus 4. No, I did plus 14x.
Oh, so did you got this far right here?
Yeah.
Okay, now we won't add 14x, right? Because that would be what we would do if we were trying to move it over here to be with other x's, but we already have all constants on this side and variables on this side, so we don't really want to move anything across the equal sign. We've already got variables on one side, constants on the other.
So we just do 5 minus 4 equals -1.
But it's not 5, it's -5.
-5 minus 4.
Yes, you remember it was negative here.
Also -8.
Not quite.
-9, sorry.
Yeah.
So then you would divide -14 on each side, right?
Okay.
Yeah, that's where like I skipped that whole step right there. Wow.
Yeah, so you actually did the hard part correctly. It sounds like picking your 18, cross canceling, all of that. It was then back to the old just solving that you got yourself a little mixed up there. So what's our final answer?
It's -9 over 14 over -14.
So what's negative over negative?
Positive.
Yeah, if you keep that -9 over -14, they'll count that wrong in my lab math. So it has to be negative over negative reduces to be positive.
Wow. I'm not.
All right, any questions on that one?
No.
Patches?
No, I'm good on my end.
Okay, all right. This is your assignment right now. There's 4 problems to do together. You two, I am out of it. Okay, this is a group work that you guys work this out together. So talk your steps out loud so you can catch each other's mistakes. Because each of you have made different mistakes from the other one. So between the 2 of you, you should be able to catch each other's mistakes. So talk out each step. And I'm gonna be right here, but I am going to be not helping. Okay, as a matter of fact, I'm going to walk away so you don't think that I'm listening in on you, but talk them over with each other, okay?
Yeah.
I'm even going to mute for a minute.
You want us to do all 4 or?
Yeah, all 4 together, not on your own, together, talk them out.
All right. So
I think the least common denominator is 20.
yeah, I'm thinking it's like 20.
Yeah.
Wait,
So, or do you think it's something else?
give me a second.
Oh, never mind. It's not 20.
Yeah, because I don't think 3 goes into 20. Hold on, give me a sec. 5, 10, 15, 20,
Damn,
30. I think it might be 30, but no. No, because I don't think 4 could go into 30. 35, 40,
What about no?
6, 9, 12, 15, 18.
I'm gonna just write all the like multiples for 4, 5, and 3. So it's like
Yeah,
easy.
that's what I'm doing right now. 8, 12, 16.
Well, she said to do the biggest number, and then if the little ones go into that one.
Yeah. Well, that's where I'm stumped right now. 18, 19, 22. Because 20 can't be it because 3 won't go into it. 4
Yeah.
will, but 3 won't. 24. 28, 32, 3, 6, 9, 12, 15, 18, 21, 24, 25, 26, 27, 30. They won't go in 30 either, so that kind of sucks. 33, 36, 39, 42, 45, 32, 36, 40, 44, 48, 52. It's probably like a really, really big number or something.
I know we're over here. 1, 2, 3, 4, 5, 6, 7, 8.
I'm gonna try 60. 45, 647, 48, 51, 54, 57. I think it might be 60, yeah.
60?
Yeah, because 3 times something equals 60, and then 4 times something equals 60. And obviously 5 will go into 60, so it's kind of a big number, but it's what I got so far.
Yeah, you're right, Patches. And you guys, just to remember, just to remind you, the shortcut to that is you don't really have to do the multiples of the 2 smaller ones. Just do 5. So just do 5 and then 10 and then 15 and 20, and each time check to see if the others go in there. So you don't really need to do like 3, 6, 9. Then when you get to 1, and if you don't know, you don't have to count up by 3s. You can just on your calculator, like if you got to 60, then you could just do 60 divided by 4 and see if it goes in evenly. It doesn't give you a decimal, and 60 divided by 3. So you don't really have to count your 3s and 4s. Just check, that they can be divided, that 60 can be divided by those numbers.
Right. So then
Okay.
we would write the problem. So it'd be 60 over 1 plus or times 3 over 4 plus 60 over 1 times 1 over 5x. I need to rewrite that. 60 over 1 times 3 over 4 plus 60 over 1 times 1 over 5x minus 60 over 1. Oh, I'm confused as a motherfucker. Oh, all right. So how did you write that out? Because I kind of confused myself there.
Me?
Yeah.
I'm gonna do it exactly how, okay, 60 over 1 times 3 over 4 plus 60 over 1 times 1 over 5x minus 60 over 1 times 1 over 3 equals 60 over 1 times 4 over 5x.
Yeah, I was thinking of writing it like that, but I feel like 60, or right where it says 1/5 x minus, I feel like, is it supposed to be like a -1/3, or is that just a minus sign?
That's what I got confused with last time too. Mm,
Well, I guess we could just leave it how the way we are, and let's just keep going forward, see how that turns out. If not, well, at least we know where our mistake is.
yeah, because I just did x minus, and then I put the 60/1 times 1/.
Yeah, I'm gonna try that too. So then, obviously, the next step would be to cross cancel each denominator. I'm gonna need my calculator for this. So the 4 becomes a 1. 60 divided by 4 equals 15. So that first one would be a 15. This becomes a 1. 60 goes into 5 12 times. This becomes a 1. 60 goes into 3 20 times. Next number becomes 1. 60 divided by 5 equals 20. No, it's 12. Shit, my bad. All right, so what I got for each one was 15, 12, 20, and 12. So then we would multiply straight across, right? So like for the first one, it'd be 15 times 3. Or,
Yeah.
all right, so then we would write that. 15 times 3 equals 45, plus 12 times 1 is 12, x minus 20 times 1 is 20, equals 12 times 4 is 48x. So what I got for the rewritten thing was 45 plus 12x minus 20 equals 48x. What did you get? You got the same thing? All right. Next, I think we gotta combine the like terms.
So do you want to do minus 12x?
Yeah, so 48x minus 12x. And that would be 36x on the right side. And then we would just do the numbers, which would be 45 minus 20. That will give us 25.
So I got, after I did the minus 12 on both sides, I got 45 plus -20 or minus 20 equals 36x.
Yeah, I got that too. And then you would just do the regular numbers, which would be 45 minus 20, which is 25. And then after that, I think we have to do that last step, which would be divide by 36. So 25 over 36. I feel like that could be simplified, but I'm not really sure. So I'm just going to leave it like that. So it would be x, or 25 over 36 equals x.
Wait, you said, so 45 plus -20, what did you say the number was?
Oh, 45 minus 20, that's 25.
25.
And then after that, you have 25 equals 36x, right? So far.
Then you divide 36 divided by 36, and then
Which is just x, and then 25 over 36. I don't think you could divide that, so I just leave it like that. So it'd be 25 over 36 equals x. At least for number 1. I don't know if the teacher's here. So you can check that. But I guess we could start on the next one.
Yeah, I'm here. So down at the bottom, there's answers. So, 23 over 12 should be your answer.
I guess I could simplify the wait.
You got what? 36 over 25?
Yeah. 25 over 36.
Well, let's see real quick. Let me write down. So you guys took each of these and multiplied by 60, right?
Yeah, 60 over 1.
Okay, what did you get when you cross canceled the first one?
It would be 1, and then the other one would be where is it? I have it right here. It's 15 on the top, right?
Okay, and then when you multiplied those two together, what did you get?
I got
45.
Okay, and then what about the next one?
it's 12.
Okay, so what did you get there?
12x
Okay.
Yeah. And then for the
Um,
next one, it's 20.
So what did you get there?
negative, well, minus 20
Yeah.
Okay,
equals 48x.
5 into, let's see, 12 equals 48x. Okay,
Minus 12x.
okay.
And that's where like I started to get a little confused, like the minus 12x on both sides, which was where I got the 36x when I put 48 minus 12x.
Yeah, so you got 36x.
So then I was, then it turned into 45 plus negative 20 equals 36x.
Oh, you know what? You guys might be right. I think I have a mistake in my work when I made this worksheet. Just a second.
Oh.
I know. I think you guys are right. Let's see,
Ooh.
25 to, woo, look at that. Yeah. Oh, darn it, that moved on me. Yeah, I have a mistake on my worksheet. I'll fix that. Nice job, guys. 25 over 36. Is that what you got?
Yeah.
Yeah.
Yeah. Yeah,
Yeah.
I made a mistake on my worksheet. I have a wrong number right there. So, okay, cool. Keep going.
Okay.
All right, next one. Ugh.
I think the least common denominator would probably be 12,
Yeah, I'm thinking the same thing.
but
So it would be 12 over 1 times x over 1 minus 12 over 1 times 5 over 6 equals 12 over 1 times 3x over
just do 12 times 3 times 3x plus 12 over 1 times 1 over 4.
so then that's a lot of writing. Gotta cross cancel. So the first one would be 12x, right?
Mm-hmm.
Minus this become a 1. 12 goes into 6 2 times.
Hold on.
And then 2 times 5 is 10. Minus 10 equals 12 times 3x is 36x times. Oh wait, this comes 1. 3. Wait, I think I did something wrong. What do you have so far for the second part? Because I got 12x minus 10 equals 36x times, or I meant to put plus 3.
I got x minus 10, which would be 1 minus 10. Would it be?
Wait, what?
So after I did all the cross canceling, I kept the x the same. So I just did x minus 10 equals 36x plus 3. Does the x turn into a 1? And then do I do a 1 minus 10?
I feel like you forgot the 12 over 1 in front of the x. That's why I wrote the x in fraction form so I wouldn't get confused. It's supposed to be like 12 over 1 times x over 1, and then minus whatever the next thing is. So for mine, I got 12x minus 10 equals 36 plus 3.
Oh, x.
36x plus 3.
Yeah, 36x plus 3.
Mm-hmm.
And then
So you said 12x minus 10?
yeah, for the first part, and then equals 36x plus 3. Then I think you would combine like terms, which is the 12x and the 36x.
Oh,
Erica, do you see why he's saying it looks like you forgot to multiply that first one by 12. Remember, you have to multiply all terms by 12.
yeah, I don't know if I had to leave it alone or if I did that, because I did both, but I went with the other one. So
Yeah, well, if we have to multiply all terms by 12, then we've got to multiply x by 12 as well. So 12x. And even if that had been x minus 10, like you were saying, those aren't like terms. So you can't change this to 1 and do 1 minus 10. They're just not like terms.
So do we do minus 12x?
I'll let you guys go from here. I was just trying to make sure you understood that.
Wait, what do you have so far?
So I have what you said, the 12x minus 10 equals 36x plus 3.
Yeah, and then we would combine the like terms, which is 12x and 36x, which gives you 48x. And then you got to move the negative 10 over to the right, which would make it
So
positive 10.
plus 10.
Yeah, so then it would be 48x equals 13. And then you would divide by 48 on each side. And that would give you x equals 13 over 48.
12x equals 36x plus 13.
Wait, what?
I got 12x equals 36x plus 13.
Wait, hold up. Read that again.
12x equals 36x plus 13? Or how did you get the 48, you said?
Yeah, you got to combine. Well, I just moved it over because that's easier for me. So I moved the. Oh crap! Hold on, give me a sec. I think I messed up here.
Why do 12x divided by 12?
Hold on, I think I messed up a little bit. When I moved the 36x over, I forgot to turn it into a negative. So that's where I kind of got myself. Just give me a sec, real quick. 12 minus 36. 12 minus 30 equals, what the fuck? Negative 24. So then, oh, it's not 48x. It's negative 24x.
23 or 24?
24.
Okay. Because then I got. Oh, let me see.
Negative 10 or yeah. So it should be negative 24x equals 13. And then you would just divide by the negative 24. Wait, what
Hold
the?
Did you subtract 36x, Erica, or did you subtract 12x?
I did 12x minus 12 on, and then 36x minus 12, and then I got 10. I mean, x minus 10 equals negative 24x plus 3. So I
So you
still,
did it like this, you subtracted 12x over to this side?
and then I still need to.
So hold on a second though, you said x minus 10, but these are gone, there's no x left. Because 12x minus 12x is 0, it's not x.
Negative 10 equals 24, negative 24x plus 3.
So Patch has got negative 24x because he took this 36 over to this side, but you're taking your 12 over to this side. Well, so it's positive 36 minus 12x.
I got negative 24.
But which is larger, 36 or 12?
36. So
And what's
24.
Yeah, he's getting negative 24, but that's because he took his to the left, but you're taking yours to the right. You'll still get the same answer as each other, but so now what?
Then I do minus.
So that you add the other ones, which would be you move the negative 10 over to the right, which would turn it into a positive.
Well, that's what you're doing on your end, which is fine because you moved your 36 over to this side. So you would move your negative 10 over to that side. So that you're fine, Patches. Erica, though, she moved her X over to the right. So which term should she move?
Wait, hold on. I'm a little confused here.
Negative 13 equals 24x.
Yeah, you would move your 3. Patches, you're fine. You did your way. She's doing her way. You guys are both fine.
We're just doing it differently.
Yeah. So now what? You said you got negative 13 equals 24x. And now what?
Then
Well,
add them both by 24.
Okay. And so you're both going to get the same answer. You're both getting negative 13 over 24 equals x. And Patches, your 24 was negative, but your 13 was positive, but still you're getting negative 13/24. So you just brought yours to the opposite side as Erica brought hers, but that doesn't matter.
Okay.
Does that make sense?
Yeah.
Okay. All right, I'll let you guys keep working. I was just keeping up.
All right. Next problem, which is number 3.
Wait, so the answer is negative 13 over 24?
Yeah, you can't reduce it anymore. If you could, you would, but you can't.
Okay, so for number 3, it's just write that out real quick. 3.
Oh, that's funny. I forgot the answers are right there.
For real.
You couldn't see them till just now. Because they were kind of down there. So, and I can't get rid of this.
I have this.
Oh, you have it printed out. Good.
I'm like, oh wait, there's right there.
I'm trying to get rid of my squiggly here, but I can't seem to get rid of it. I don't know what's going on.
So I'm thinking
Okay.
the LCD is 4.
Mm-hmm.
So then we would do 4 over 1 times 3t over 4 minus 4 over 1 times t over 2 equals 4 over 1 times 1 over 1. Okay, and then we gotta do the cross cancel. 4 goes into 4 one time. 2 goes into 4 2 times. 4 goes into 1 4 times.
So I got 3t minus 2t equals 4.
3t minus 2t minus 4. Yep, sounds about
Minus
right.
4? Minus 4?
Oh, equals 4.
Okay.
So you would combine like terms, which is on the left. 3 minus 2 is 1.
So
Or
x equals 4, because, well, I got 1x 4, but, you know, the x equals 4.
yeah, I got t equals 4 basically. How does that sound, Miss Yancy?
Yeah, that's good.
All right, on to the next. Where's that at? Number 4. Y over 5 minus y over 4 equals 7/20. The least common denominator is 2. Yeah, it's 20. So we would do 20 over 1 times y over 5 minus 20 over 1 times y over 4 equals 20 over 1 times 7/20. So cross cancel, 20 goes into 5, 4 times. 4 goes into 20, 5 times. 20 goes into 20 one time. Multiply straight across, 4 times y is 4y, minus 5 times y is 5y.
I got 4y minus 5y equals 7, and then negative 1y.
Equals 7.
And then you do plus 1, so it's just y. So y equals Jesus Christ.
Wouldn't it just be like y equals 7? Because I mean, you can't really divide it, or negative 7, I guess you could do, but.
What did you guys get when you cross canceled? I'm catching up. I've got this weird thing I'm trying to get rid of. Ooh.
When we cross canceled, the first one was 4, the second one was 5, the third one was 1. Yeah. And then after that, we did the multiply straight across, which was 4y minus 5y equals 7. And then we just combined like terms. That gave us negative 1y equals 7.
Now
Well,
what?
this is what I don't understand. I did plus 1y, well, plus 1 on both sides.
Oh, well, see, remember, if this was y minus 1 equals 7, then we would add 1 because we do the opposite. But this isn't.
So it just
What's
stays like that.
No, because we need y, not negative 1y.
Oh, so then you would divide it by negative 1?
Right. Whatever number that is in front of the variable, you divide it because that's the coefficient. You always divide that on that last step. You divide the coefficient.
So then it would be negative 7, right? Or
Right.
But how -7? Oh,
Because
never,
you divide 7 divided by -1, which equals -7.
never mind. I get it.
Yeah?
Yeah.
All right. I think you guys got it. Do you feel like you have it?
Yeah.
Good. I'm going to stop recording here for a minute.